Hello, and welcome to the final installment of Peabody Library's 2025 Spring Workshops on Artificial Intelligence. This is the ethics of AI. I'm Jennifer Castle, the librarian for Human and Organizational Development, and I want to thank you for sharing your time with me today. Before we begin, a presentation on the ethics of AI cannot be fully explored in an hour due to the breadth and complexity of the topic. The ethical considerations surrounding artificial intelligence spanned numerous domains, including privacy, bias, transparency, accountability, safety, and the social impacts of AI systems. Each area requires in-depth examination and discussion to address the nuances and challenges involved adequately. Furthermore, the rapid pace of AI development and the evolving nature of the technology adds a layer of complexity that would be difficult to cover comprehensively within 1 hour. A more thorough explanation or exploration of the ethics of AI would likely require a multi-session or a multi-day event to allow for a comprehensive analysis and meaningful dialogue on this critical issue. So please keep this in mind as we move through the presentation. So before we look at the ethics of AI, we need to set out what ethics means in the first place. Ethics seeks to answer questions like what is good or bad, or what is right or what is wrong, or what is justice, well-being, or equality. As a discipline, ethics involves systematizing, defending, and recommending concepts of right and wrong in conduct by using conceptual analysis, thought experiments, and argumentation. So AI ethics is a branch of ethics that focuses on the moral issues surrounding artificial intelligence. It's crucial in guiding the responsible development and use of AI technologies that align with human values and societal norms. It examines questions about fairness, transparency, accountability, and the social impact of AI. According to the Turing Institute, AI ethics is, quote, a set of values, principles, and techniques that employ widely accepted standards of right and wrong to guide moral conduct in the development and use of AI technologies. All right, so now let's address some key ethical concerns of AI. So bias and fairness. AI systems can perpetuate or amplify human biases present in the data used to train them. This can lead to unfair treatment or discrimination against certain groups. It's important to proactively identify and mitigate sources of bias to ensure AI is fair and equitable. Privacy and surveillance. So the widespread use of AI enables the mass collection and analysis of personal data, threatening individual privacy. Technologies like facial recognition and predictive analytics are areas of particular concern. There is a strong need for responsible data practices and robust protection of sensitive information. Transparency and explainability. Many AI systems are what we call black boxes, with opaque reasoning behind their decisions. This lack of explainability makes auditing systems for errors or biases difficult. Pursuing transparent and interpretable AI systems should be a priority. And human agency and oversight. As AI systems become more autonomous, humans must remain in the loop, especially for high-stakes decisions. Governance frameworks are needed to ensure there is accountability and human oversight of these powerful technologies. So I'm going to stop right here and make an important note. And I cannot stress this enough. AI needs human oversight. AI absolutely must have diverse human oversight from across disciplines and the ability to override AI decisions at any point, from beginning to the end of AI life cycles. We must ensure it's safe, equitable, and accurate by doing things like regularly auditing AI systems for bias and fairness, incorrect and harmful outputs, etc. Constantly adjusting models and data sets to mitigate detected biases, disparity, false information, etc. Installing mechanisms for oversight and redress, rigorously testing AI systems for disparate impact across demographic groups, introducing randomness or diversity into recommendations, monitoring outcomes and impacts over time, anonymization, establishing clear lines of accountability and liability for AI systems and others. So, and then finally, for societal and environmental impact, the increasing use of AI could have significant societal impacts such as job displacement and increase inequality. The significant environmental cost of developing AI should be considered. It's important to proactively address these challenges and work toward beneficial AI that helps humanity as a whole. Addressing these concerns will require integrating ethics into every stage of AI research and development, promoting multi-stakeholder collaboration, and encouraging public dialogue on the impacts of these transformative technologies. All right, so moving on. The first thing we're going to look at more in depth is bias and fairness. These are significant ethical concerns in developing and deploying AI systems. AI models learn from the data that they are trained on, and if that data contains human biases, the model can incorporate and even amplify those biases in its outputs. This can lead to unfair or discriminatory outcomes for certain groups of people. So some key issues related to bias and fairness in AI include, biased training data. So if that data used to train AI is biased, like it doesn't represent, is not representative of the entire population, or it has historical biases, the model will learn and perpetuate those biases. So AI learns from the data. So biased data leads to biased models. Historical data often contains societal biases, like for hiring or in criminal justice. And then the underrepresentation of certain groups in data, so like minorities and facial recognition data sets. And then proxy discrimination, like even if sensitive attributes like race are removed, AI can learn from correlated proxies. So by zip code, for example, can be a proxy for race due to housing segregation. This can lead to discriminatory outcomes, even without explicit bias. And then it can also perpetuate feedback loops. So they'll be fed back as training data, which is just amplifying that bias over the time. So an example would be like predictive policing leads to more arrest in over-policed communities. And then a lack of diversity, which is homogenous teams can embed their own biases into systems. And a lack of diversity limits the ability to spot and mitigate bias. So some key issues include like a lack of representation from minority groups and diverse disciplines, results in narrow perspectives and blind spots regarding bias and fairness. And diversity is really crucial for identifying biases and developing equitable solutions. And so the impact of the lack of diversity. So AI systems are reflecting the biases and limited perspectives of their creators. Their failure to spot discriminatory outcomes that disadvantage underrepresented groups. Products and services that don't work well for large segments of the population, and then generally just mistrust of AI among communities who are not represented in its development. So to improve diversity in AI, you need to actively recruit and retain diverse talent in AI roles. You need to address barriers to entry and create inclusive workplace and cultures. You need to collaborate with domain experts and those affected communities. Should be mandatory bias and fairness training for for AI researchers and developers, and funding initiatives to increase representation throughout the AI pipeline or life cycle. So greater diversity in AI is essential for developing fair, inclusive, and trustworthy systems, but it requires proactive, sustained commitment from industry, academia, and government. And then with feedback loops, where the biased outputs are fed back into the system as training data, which just reinforce and amplify those biases over time. How it happens is an AI model produces biased output based on biased training data. And then those outputs are used to make real world decisions like who gets a loan. And then that data on those decisions is fed back into the AI model as new training data. And so the model just learns from this new data, further amplifying the original bias. And then the cycle repeats with the bias increasing at each iteration. So examples of these like feedback loops are predictive, like I mentioned before, predictive policing, hiring algorithms. So biased hiring leads to a homogeneous workforce, right? And then recommendation systems, popularity bias leads to certain items being recommended more and becoming more popular. So left unchecked, feedback loops can cause initially small biases in the AI systems to spiral into severe and systemic discrimination. And then disparate impact. Even if AI models are even if an AI model is not intentionally biased, it can still have a disparate impact on certain protected classes. So, for example, like by race or by gender. Even if the system does not explicitly use those protected attributes in its decision making. So, this is a complex legal and ethical issue. And some key points about this disparate impact is that it can occur even in the absence of intentional discrimination. Results from AI models, learning patterns and data that can correlate with protected attributes. You know, like I mentioned, it's complex and ethical. Um, so disparate impact is prohibited in specific domains like employment and housing. And then detecting disparate impact requires, analyzing AI outcomes across different demographic groups. What causes these disparate impacts is, again, that bias training with historical inequities, the use of proxy variables that correlate with protected attributes, failure to account for underlying differences in opportunities and resources between groups, and then a lack of model interpretability, masking discriminatory patterns, that black box that I mentioned earlier. So identifying and mitigating disparate impacts is crucial for ensuring that AI systems are fair and not discriminatory. It requires proactive analysis and commitment from AI practitioners and governing bodies to equitable outcomes. Ultimately, ensuring AI is fair and unbiased is a socio-technical challenge that requires addressing issues at the intersection of technology and society. Again, it's complex, but it is crucial to get it right as AI is deployed in increasingly high stakes domains. So moving on to privacy and surveillance. So there's pervasive data collection in AI. AI systems often rely on vast amounts of data collected from many sources. So things like your online activities, so your browsing history, social media, purchases, your mobile devices, so location tracking, app usage, sensors and smart devices, surveillance cameras and facial recognition, and government and corporate databases. This pervasive data collection raises serious privacy concerns, because it reveals intimate details about individuals. It enables profiling and tracking of behavior and can be used for manipulation and control. And then there's also a huge risk of data breaches and misuse. So with moving on to inferential analytics, so that involves AI drawing insights and making predictions about individuals based on patterns and data, even if that data doesn't directly contain the inferred information. So for example, inferring a person's political views based on their online behavior, or predicting sexual orientation from facial features, or guessing income level from shopping history. This raises serious privacy concerns because of sensitive attributes that can be inferred without an individual's knowledge or consent. It can reveal intimate details and enable profiling. And then facial recognition is a type of technology that can identify or verify individuals from images or video. And this really it raises significant privacy concerns because it enables real-time identification and tracking of people in public spaces. It can be used for invasive surveillance by governments and corporations. It is often deployed without consent or transparency. It disproportionately impacts marginalized communities already subject to over-policing, and then it's frequent misidentifications, especially for people of color. The power of facial recognition to erode privacy and enable tracking makes it one of the most concerning AI applications from an ethics perspective. Proactive governance is crucial. I feel like I'm just beating a dead horse here. Proactive governance, human involvement is absolutely crucial. So moving on to predictive policing. Predictive policing is when AI analyzes data and predicts where crime may occur or who may commit crime. And some key issues include, it often relies on biased historical crime data. It can create feedback loops that reinforce biases. It leads to over-policing of minority neighborhoods. It's not very effective at actually predicting crime, and it lacks transparency and accountability. And then finally, manipulation and control. AI systems can enable troubling new forms of manipulation and control by hyper-targeting. Hyper-targeted advertising can exploit personal vulnerabilities. Recommending algorithms can shape beliefs and behavior. Predictive analytics can be used to profile and penalize people. AI-generated media can spread persuasive disinformation, and pervasive surveillance can lead to self-censorship and conformity. Okay, now moving on to transparency and explainability. Like I mentioned before, many modern AI systems, particularly those based on deep learning, are essentially just, black boxes where the reasoning behind their outputs is opaque to humans. So some key issues in this area include a lack of interpretability. So complex AI models, even for experts, can be complicated to interpret. And this makes it hard to understand how the system arrives at its decisions. So we need to understand how the AI arrived at a particular output and identify potential biases or errors in the model's reasoning. You need to assign accountability for AI-made decisions, build trust with users and stakeholders, and meet legal requirements around explanations. As AI is deployed in healthcare, criminal justice, and financial services, solving the black box problem is crucial for responsible and accountable use. And then hidden biases. I've mentioned this before, but without transparency, it's challenging to identify and mitigate hidden biases in AI systems that could lead to discriminatory outcomes. So AI can learn biases, like I mentioned before, from training data. That biased outcome can result in AI picking up on subtle correlations and perpetuating them. Lack of diversity on AI teams means that those biases may go unnoticed during development and testing. And then biases can be difficult to identify and mitigate without careful analysis and auditing. And then accountability challenges. So if we can't understand how an AI system works, it's hard to hold it accountable for its decisions or assign liability when things go wrong, because it is difficult to assign liability when decisions cause harm. The black box nature obscures responsibility. AI developers may not foresee all potential misuses, and the lack of clear legal and regulatory frameworks around AI accountability just makes the entire situation worse. So robust accountability measures are essential to ensure responsible development and deployment as AI systems are entrusted with more consequential decisions. So with uninformed explanations, they are not meaningful or informative enough to provide fundamental understanding. So some key issues are, explanations that are too high level or too generic to be useful. They fail to properly articulate the key decision factors, often correlations without causal reasoning, and then, with presenting information in ways that are misleading or hard to interpret. And then finally, trust and adoption. The lack of transparency and explainability can undermine public trust and hinder the adoption of AI technologies in high stakes domains like healthcare and criminal justice, because, there's a reluctance to rely on black box systems for critical decisions. There are obvious concerns about hidden biases and potential for unfair outcomes. There's fear of unintended consequences with the lack of accountability. And then, not being able to verify AI systems are safe or reliable. So as AI is deployed in increasingly critical domains, ensuring these systems are transparent and explainable is crucial for ethical decision-making, accountability, and public trust. It is definitely a complex challenge, but it is one essential for realizing AI's benefits responsibly and trustworthy. Okay, so human agency and oversight. As AI systems become more autonomous and capable, ensuring human agency and oversight is a key ethical concern. This involves ensuring that humans remain in control of AI systems, especially for high-stakes decisions, and that governance mechanisms are in place to ensure accountability. Some key issues include the loss of human control. So as AI systems become more complex and autonomous, there's a risk that humans may lose meaningful control over their operations and outputs. The loss of human control is a key concern with advanced AI systems. So as it becomes more autonomous and complex, it may pursue goals that are misaligned with human intent. It may have the ability to learn and adapt in unexpected ways. It may be operating at speeds and scales beyond human reaction times and performing functions that are not fully understood by human overseers. And because of this, it's difficult to intervene. So even when humans are nominally in control, the speed and complexity of AI systems can make it difficult to intervene in real time when issues arise. And so that lack of interpretability masking potential issues, until it's too late. And with insufficient human understanding of the system to know when and how to intervene. So there's practical difficulties in halting or altering the behavior of a deployed system. So then misuse and unintended consequences, without proper human oversight, AI systems can be misused or have unintended negative consequences, such as like using facial recognition for invasive surveillance, for AI-generated disinformation, or to undermine truth and democracy. May create algorithms, may reproduce or amplify societal biases, may include job losses and economic disruption from automation. And then there could even be AI accidents causing physical harm or damage. And with that, there are accountability gaps. So it's unclear who is responsible for an AI system's decision. So it can be challenging to hold anyone accountable for harm caused. So difficulty assigning liability for harmful AI decisions or actions. There is lack of clear legal and regulatory frameworks around AI accountability, particularly here in the United States. AI developers, may not anticipate or be held responsible for negative impacts. And then there's that many hands problem that AI systems touch many parties, none with full accountability. And that might lead to value misalignment. So if AI systems pursue goals misaligned with human values, significant harm could result. So things like the systems could optimize for the wrong objective function. There could be difficulties specifying and encoding human values into AI rewards. The system might find undesirable ways to achieve their goals, or misalignment just may become more severe as AI becomes more capable. So ultimately, again, ensuring that humans remain in control of AI systems is essential for their safe and beneficial deployment. Maintaining meaningful human agency and oversight will require a combination of technical safeguards, organizational practices, and governance frameworks. Okay, so moving on to societal impacts. The widespread deployment of AI systems can profoundly impact society and the environment. So it's crucial that we proactively consider and address these implications. So with societal impact, there's job displacement. AI automation could lead to significant job losses in certain sectors, potentially exacerbating inequality and social upheaval. This can lead to, widespread automation of jobs in manufacturing, transportation, retail, and other industries, can disproportionately impact lower skilled and less educated workers. It has the potential to exacerbate income inequality and social divisions. And there are challenges in retraining displaced workers for new roles. So with algorithmic bias, As we've mentioned before, AI systems can perpetuate and amplify societal biases. So some issues with that are, the historical biases and underrepresentation in the training data gets baked into the models. Models can learn proxies for protected attributes that perpetuate biases. Homogeneous development teams may fail to anticipate or check for bias. And then again, that opaque black box model can obscure biased logic. With that, there's also privacy erosion. As we've mentioned before, ubiquitous data collection from online activities, mobile devices, etc. AI-powered surveillance via facial recognition and predictive policing, inferring sensitive attributes from non-sensitive data, and then enabling hyper-targeted profiling manipulation, which could lead to concentration of power. The benefits of AI could accrue disproportionately to large tech companies and governments, concentrating power in the hands of a few. And with that centralized control over vast troves of data and powerful AI capabilities, there will be a lack of competition and accountability in the AI industry. There's potential for AI-driven surveillance and social control by authoritarian regimes, and the outsized influence of AI companies on the direction of technology. So it's a real existential risk. If not developed and governed properly, advanced AI systems could pose existential risks to humanity in the long run. And then finally, environmental impact. Energy and resource use. Training and running large AI models consume significant amounts of energy and computational resources, which contributes to carbon emissions. Training AI models requires vast amounts of data and processing power. The data centers housing AI hardware have a sizable carbon footprint, and as the demand for AI accelerates, hardware obsolescence and e-waste will happen. With that, there's also rare earth mining. So AI systems rely on hardware made with rare earth elements, and the mining of which can have severe environmental consequences, which include highly polluting extraction and processing methods, destructions of habitats and ecosystems at mining sites, health impacts of workers in nearby communities, and there are geopolitical risks from concentrated supply in certain countries. So as AI drives up the demand for rare earths, making their sourcing more environmentally and socially sustainable is absolutely critical. And then with e-waste, the rapid pace of AI hardware development can lead to high device turnover and a growing e-waste problem, which includes short lifespans for devices like graphic processing units and application-specific integrated circuits as they become obsolete. There's difficulty in recycling complex AI hardware components. E-waste is often shipped to developing countries with lax regulations, and the toxic materials in e-waste pose health and environmental risks. So by addressing e-waste challenge requires things like extending the useful life of AI hardware through modular design and upgrades, or developing AI-specific hardware recycling processes, or improving e-waste handling regulations and enforcement, and supporting the development of circular economy for AI hardware. So as AI accelerates hardware turnover, so it's going to be really critical to implement sustainable end-of-life practices for devices to minimize waste and environmental harm. But you also may think about, what about AI for environmental good? On the positive side, AI may be also harnessed to help address environmental challenges like climate change, biodiversity loss, and pollution. It can monitor ecosystems and wildlife populations. It can optimize renewable energy systems. It could improve the efficiency of transportation and industrial processes. It can accelerate the development of clean technology, and it can model climate change and its impacts. So realizing AI's potential for environmental good really will require like directing AI research and development towards sustainability practices or challenges, excuse me, and providing access to ecological data and computing resources. It also will require collaborating across disciplines to develop impactful AI applications. It will also require ensuring the development of AI itself follows sustainable practices. So addressing these impacts requires a concerted effort from policymakers, companies, researchers, and citizens to proactively shape the trajectory of AI for societal and environmental benefit. With foresight and proactive governance, AI transformative potential can be steered toward positive societal and environmental outcomes. All right, so let's talk about the 5 ethical principles of AI. So according to a recent study, AI ethics has quite rapidly converged on a set of 5 principles. So the first is non-malfeasance. The second is responsibility and accountability, transparency and explainability, justice and fairness, and respect for human rights such as privacy and security. Okay, so the 5 principles each answer different questions and focus on different values. So malfeasance is, should we use AI for good and not cause harm, which is the principle of non-malfeasance? Who should be blamed when AI causes harm, which is the principle of accountability? Should we understand what and why AI does whatever it does, which is the principle of transparency? Should AI be fair or non-discriminative, which is the principle of fairness? And finally, should AI respect and promote human rights, which is the principle of respecting fundamental human rights? Before we continue, I want to note that AI ethics is the first on the list when speaking of AI and its social implications. However, there are theoretical frames exist for looking at ethical codes for algorithmic or data-driven systems. So for example, questions about the social impact of AI come up in fields like algorithmic cultures or gender studies and media studies. Correspondingly, the cognitive and psychological aspects of human-machine interaction shape the question of an appropriate ethical framework for AI. So simply put, there is much more to AI ethics than just data and algorithmic ethics. So let's start with the first one, non-malfeasance. So the principle of beneficence or non-malfeasance states to do good, while the principle specifically of non-malfeasance states do no harm. Although these two principles may look similar, they represent distinct principles. Beneficence encourages the creation of beneficial AI, so like AI should be developed for the common good and the benefit of humanity, while non-malfeasance concerns AI's negative consequences and risks. So generally, AI ethics have been primarily concerned with the principle of non-malfeasance. Discussions have focused chiefly on how developers, manufacturers, authorities, or other stakeholders should minimize the ethical risks. So discrimination, privacy practices, physical and social harm that can arise from AI applications. Often these discussions are stated in terms of intentional use, malicious hacking, technical measures, or risk management strategies. Critics claim that the emphasis on non-malfeasance makes ethics a matter of finding technical solutions for technical problems. Moral problems are seen as things that can be solved by technical fixes or by good design alone. The broader ethical and societal context in which technical systems are embedded is forgotten. Many significant issues that direct the control, governance, and societal dimensions of AI are just ignored. So technology researcher Eugenia Morozov calls this tech solutionism, the conviction that problems caused by technology can always be fixed by more technology. So as a result, profound and complex ethical problems are oversimplified and not answered. So one of the questions is the problem of the common good. Like, what exactly does that mean? So let's take a look at one classical philosophical answer. Utilitarianism. So it is a family of ethical theories. It conceives benefits as actions that maximize well-being across all affected individuals. Utilitarianism is a version of consequentialism, which states that consequences of any action are the only standards of right and wrong. For utilitarianist, utility or benefit is defined as well-being or happiness. So for instance, Jeremy Bentham, the father of utilitarianism, characterized utility as, quote, that property that tends to produce benefit, advantage, pleasure, good, or happiness, or to prevent the happening of mischief, pain, evil, or unhappiness to the party whose interest is considered. Utilitarianism offers a relatively simple method for deciding whether action is morally right. So to do that, we should follow these steps. So firstly, we identify the various actions that we could perform. Secondly, we estimate the benefits and harm that would result from each action. And then third, we choose the action that provides the most significant benefits after the costs have been taken into account. Utilitarianism provides many intriguing ideas and concepts. So, for example, the diminishing marginal utility principle is helpful for many purposes. Like, according to this principle, an item's utility decreases as the supply of units increases, or vice versa. So, for example, when you start to work out, at first you benefit greatly, and your results get dramatically better. However, the longer you continue working out, the smaller the impact of each training session. If you work out too often, the utility diminishes and you'll start to suffer from symptoms of overtraining. So there are some challenges in this practice. So there's difficulty in accurately measuring and comparing the benefits and harms resulting from different actions. Accounting for the diminishing marginal utility of goods and services as supply increases, and addressing moral considerations beyond the aggregate consequences, such as individual rights and fairness. Ultimately, the key challenges in applying utilitarianism in practice relate to quantifying and comparing diverse outcomes, accounting for diminishing returns, and balancing consequentialist thinking with deontological considerations. These limitations must be carefully navigated when utilitarian reasoning to evaluate the ethics of emerging technologies. So moving on to responsibility and accountability. Responsibility can be legal or moral. Legally, an actor is responsible for an event when a legal system is liable to penalize that actor for that event. Morally, an actor is responsible for an act if they can be blamed for the action. Moral and legal responsibility are different things. They do not always coincide. An agent can be legally responsible even if they are not morally responsible, and vice versa. So we'll focus only on the moral aspects of responsibility today. So accountability means being responsible or answerable for a system, its behavior, and its potential impacts. It is an acknowledgement of responsibility for actions, decisions, and products. In AI ethics, there are three different senses or dimensions of accountability, and they point to other means of action. So including the question or determining of the responsibility is which individuals or groups are accountable for the impact of algorithms or AI? Who is responsible for what effect within the overall socio-technical system? A feature of the societal system that develops, produces, and uses AI, and then it's also a feature of the AI itself. So responsibility and accountability must be proactively built into the development life cycle and operation practices around AI systems, particularly as they are employed in high-stakes domains. Ensuring clear responsibility involves assigning specific human roles for oversight and decision-making throughout the AI lifecycle, from design and development to deployment and monitoring. This helps establish who is accountable when something goes wrong or unintended consequences arise. This requires the collaboration of developers, deployers, policymakers, and the public to create effective governance and oversight. So, ensuring that there is a clear responsibility involving assigning specific human roles. And so, as mentioned repeatedly before, accountability is challenging with AI systems due to their opacity and complexity. those black boxes, like I mentioned. So we need to improve the interpretability of AI systems. So we need to enable accountability by clearly understanding the key factors driving a particular outcome. There also needs to be a comprehensive audit trails and logging mechanisms. So they record how the system was developed, what data was used to train it, and how it's been deployed over time. This information is key for investigating issues and holding the appropriate parties responsible. Another important aspect of responsible AI development is proactive testing for potential misuse and unintended impacts. So developers need to carefully consider the range of ways that their AI system could be used or abused in the real world and implement safeguards to prevent foreseeable harm. And then finally, establishing responsibility in for AI systems requires updated legal and regulatory framework. So existing liability laws and regulations often do not cleanly map onto the unique challenges posed by AI. In collaboration with industry and the public, policymakers need to develop new governance approaches tailored to the realities of AI to ensure these robust systems remain accountable to society. So here's just an anecdotal story to clarify what I'm trying to say. In the city of Amsterdam, parking control is partially automated and in use across 150,000 street parking spaces in the city. The service follows a three-step approach. So you scan cars equipped with cameras, drive through the city, and use object recognition software to scan and identify the license plates of surrounding cars. After identification, the license plate number is checked against the National Parking Register to validate if the car has permission to park at a given location. Whenever no payment has been made for current parking, a case is sent to a human inspector for further processing. So then the parking inspector uses the scanned images to remotely access whether there is a special situation such as loading or unloading or stationary cars in front of a traffic light. The parking inspector may also verify the situation on site by scooter. Whenever there is no valid reason for non-paid parking, a parking ticket is issued. So parking control services provide an example of how algorithms are increasingly used for automating public services. As algorithms are exact, fast, and precise, they can often promote better service efficiency, reliability, and consistency. But paradoxically, algorithms can also make systematic errors, be biased, and cause serious harm. So for example, scanning systems may malfunction or suffer from bugs. They may make mistakes and suggest tickets be issued on invalid grounds. So in those cases, who should take responsibility and on what grounds? So although we say things like, yes, it was the algorithm's fault and it's responsible for the wrong decision, we do not literally mean that contemporary algorithms would be morally guilty. Instead, the algorithms are causal factors that underlie the decisions. Like mere causes, however, differ from morally responsible actions. Even though algorithms themselves cannot be held accountable, they are not moral or legal agents. Organizations designing and deploying algorithms can be taken to be morally responsible through governance and governance structures. So thus, in this case, the city of Amsterdam, it is the human inspector that makes the final decision and also who takes responsibility. However, one day the human inspector may be replaced by algorithms too. So who then will take responsibility? So as it turns out, it has been notoriously difficult to set specific criteria on how exactly the responsibilities should be individuated, directed, and defined. So in many countries, there are ongoing debates on these questions. International actors like the European Union and the G7 have addressed them as open challenges. But why is it so difficult to set criteria on who is responsible? Well, first, the quality of responsibilities differ. Like an actor is responsible for a specific action or a mission, but the quality of responsibility is dependent on the stakeholder. Thus, although by choosing an action, you may commit the responsibility, the quality of responsibility is dependent also on your properties. Intelligence technologies complicate this more. So as we delegate more and more decisions, making tasks and functions to algorithms, we also shape decisions-making structures. AI is augmenting our intelligence by giving us more computational power, allowing better predictions and enhancing our sensory apparatus. Human and machines become cognitive hybrids. They cooperate cognitively and epistemically, both at the individual and collective level. This creates systemic properties. And it is often thought that it is sufficient enough that a human stays in the loop or on the loop, meaning at some point of decision making, a human individual would be able to monitor or intervene in the artificial system. However, as algorithms enter into decision making, say in public sector governance, the collective decision making can take a very complex and highly distributed form. To individuate and address the factors in a way that would guarantee that a human stays in or on the loop may be really difficult. And then secondly, the technology can take a persuasive form. It influences and controls people. A classic example is the beeping sound of seatbelts. In many cars, if the seatbelt is not fastened, it will cause a constant beeping sound. This can be taken as a form of controlling influence. In this case, a kind of coercion. The driver can only stop the sound by fastening the belt. Contemporary algorithmic applications can have more and more such features. They propose, suggest, and limit the options. But an action is done voluntarily only if the action is done intentionally, right? So the one acting is, quote, in control and is free from controlling influence. Is the driver free from controlling influences if the seatbelt system forces him to react to the beeping sound? Or are we free from control if the algorithms decide whose pictures we'll see in the dating sites or what music we're about to listen to? What exactly is the difference between algorithmic suggestion, control, or manipulation? Naturally, persuasive technology should comply with the requirement of voluntariness to guarantee autonomy. Like algorithms complicate this issue since the voluntariness presupposes a sufficient understanding of the use of specific technology. But what does it mean to understand? And what is the sufficient degree really? Like what is the correct reading of understandability, transparency, explainability, or auditability? How much and what exactly a user should understand about technology? When can one genuinely estimate whether or not they want to use that particular technology? So this leads into transparency and explainability. So transparency is a property of a system that makes it possible to get certain information regarding a system's inner workings. But what information that is and whether it is ethically relevant depends on whether the ethical issue we are trying to answer. So transparency itself is ethically neutral and is not an ethical concept. Instead, it constitutes an ideal. Transparency is something that can manifest in many different ways, and it's something that we can present a solution for underlying ethical questions. So providing transparency and explanations is important for several reasons, like enabling humans to understand and trust AI system outputs to identify and potential biases, errors, and unintended consequences. It supports accountability by showing how a decision was made and facilitating human oversight and intervention when needed. Transparency and explainability are particularly crucial in high-stakes domains like healthcare, where understanding the reasoning behind AI recommendations is essential for clinicians and patients. They are also important for complying with emerging regulations like the EU AI Act, which mandate transparency and explainability for certain high-risk AI applications. So in this sense, transparency is relevant at least to three following issues, right? So the justification of decisions. Good governance in public or private sectors involve non-arbitrariness of decisions. So this applies to any decision-making that has an ethically or legally relevant effect on individuals. Non-arbitrariness means access to justifications about why was this decision reached and on what grounds. Furthermore, especially in the case of public governance, the capacity to contest and appeal is crucial. This represents a demand to right wrongs. And then there's the right to know. According to human rights, people are entitled to explain how decisions were made to maintain genuine agency for freedom and privacy. Freedom entails the right to get answers to questions such as, how am I being tracked? what kind of inferences are being made about me, and how exactly have the inferences about me been made? And then there's the moral obligation to understand the consequences of our actions. So as a community, we also have a responsibility to manage risks. There is a moral obligation up to some reasonable level to understand and predict the consequences of the kinds of technologies one brings into the world. That is saying, we can't understand now what it will do is not a valid argument for unleashing a system that causes harm. Instead, it is our moral duty to explore the possible risks. So these 3 points can all be summarized as calls for sufficient information. Do we know whether and to what extent this algorithmic decision is justified? Do I understand how inferences about me are being made? And to what extent am I responsible for the system's actions? And how much should I know about the system's inner workings to take that responsibility? Which leads to fairness. So fairness and bias are the most discussed ethical issues related to contemporary algorithms. So why are they so central? Well, fairness is a fundamental element of social stability. As the philosopher John Rawls remarks, the stability of a society or any group depends upon the extent to which members of that society feel that they are being treated in a just manner. When some of society's members feel that they are being treated unfairly, it usually creates a foundation for social unrest, disturbances, and strife. People hold social unity only to the extent that their institutions are fair. And then, as Immanuel Kant remarked, human beings have the same dignity. By virtue of this dignity, they are entitled to be treated as equals. If individuals are mistreated, especially on arbitrary grounds, their fundamental human dignity is violated. And when this violation is implemented in practice, it leads to discrimination. So here's an example. A school's matricular exams were canceled due to COVID-19. Teachers estimated student performance to determine grades for university admissions. An algorithm adjusted these estimates based on schools' historical performance to combat grade inflation. Now, while the national grade distributions matched previous years, the algorithm downgraded 40% of the teacher predictions, disproportionately affecting low-income students hoping to attend university. So, however, as the example of a grade inflation algorithm illustrates, fairness is a complex issue. The algorithm was designed to correct grade inflation because it was considered unfair if students got an unfair grade advantage. But as a result, paradoxically, the algorithm reinforced already existing societal bias. So there are different varieties of fairness. Philosophers have proposed various definitions of fairness. According to Aristotle, equals should be treated equally and unequals unequally. This principle of equality states that individuals should be treated the same unless they differ in ways relevant to the situation in which they are involved. So an example is if Alan Turing and Ada Lovelace got the same grades from the exams and there are no relevant differences between them or the exams they take, they should be given the same grade. And if Turing would get a better grade than Lovelace simply because he has a higher socioeconomic status, then it would be unfair. Why? Because socioeconomic status should not be relevant when grades are given. However, the principle of equality has been criticized for being blind. The principle does not consider that not everyone starts from the same position or that individual differences matter. In contrast to equality, equity does not promote fairness by categorizing everybody equally, but by giving everyone equal access to the same opportunities. For example, if there are situations where the differences in socioeconomic background are relevant for criteria for treating people differently. So, for example, like most people accept it as fair when the government gives social benefits only to those citizens who really need them and does not provide benefits to all. But equality means that everybody is treated the same, whereas equity means that everyone gets what they need to be successful. So next is discrimination and biases. So what is discrimination? One definition is a difference in the treatment of individuals based on their membership in a group. And another is discrimination is differential treatment based on perceived membership in a socially salient group, which causes social harm. But what about these harms? What are they? So allocative harms are situations where an individual is made worse off by regarding the available resources. So here resources should be understood broadly as food, cars, cell phones, other material goods, and the services and opportunities provided. A lower salary for the same work is most definitely an allocative harm, but so is denying the opportunity for a job interview based on one's gender or denying credit based on it. And then there's representational harms that don't concern the distribution of goods. Instead, they are concerned with the representation of groups and individuals. So this class includes harms such as denigration, stereotyping, misrecognition, and exnomination. So exnomination is a term regarding or term originating from media studies. It means a practice where a specific category or way of being framed as the norm by not giving it a name or not specifying as a category in itself. So for example, athlete versus female athlete. Representational harms affect the narratives we construct about relevant social groups. So by amplifying stereotypical views, degrading the social status of individuals, and framing specific ways of being the status quo, representational harms manufacture unwarranted justifications for oppressive practices. Well, bias has recently become the prototypical issue for AI ethics since the hope that algorithms' exact formality makes them immune to partiality has turned out to be sorely false. There are three different meanings of bias. So in statistics, it's discrepancy of a sample statistics versus the actual statistic of the population. In cognitive science, it's a mode of reasoning likely to produce an incorrect or skewed result. And in social justice, it's a morally suspect discrepancy in a treatment of people. So with a non-representative sample, bias enters AI systems through non-representative data sets that don't faithfully reflect the world. So manipulating the learner's view by amplifying some phenomena and suppressing others leads to skewed models. Like, for example, facial recognition systems perform disparately across ethnicities due to data sets dominated by white males. And then label bias, so data doesn't speak for itself, but through our interpretations. Like discrepancies between what's measured and investigated can introduce bias. Like arrests, a proxy for crime, correlate differently across socially salient groups. So inferences from such data can repeat and just reinforce the injustices that produce the data. And then there's also like cultural unawareness. Human deployment, interpretation, design, and maintenance choices can create AI biases. Decisions about what constitutes real signal versus noise, often seen as janitorial work, go unnoticed in many stages, such as data cleaning and input sanitation. So far, we have found a reasonable definition of discrimination and have at least two anecdotal examples of AI systems participating. But in both cases, the discriminatory practices arise from biases in the AI system itself. We have some questions to answer if we want to get a handle on this issue. Like, how do AI systems become biased? How can we measure if a system is biased? How can we fix it? Bias can enter a system like many different ways. The examples I mentioned are just a few of the mechanisms at play. A critical point here is that when analyzing AI systems for unfairness, it's not enough to look at the algorithms. Rather, unfairness can arise because of historic, cultural design, data management, or deployment reasons, and thus, the whole process of AI development must be scrutinized. How do we make AI systems more fair and less biased? Well, there's no panacea for bias, partly because many of the different ways bias can manifest, and partly because there's no single definition of an algorithmically fair outcome. Well, there's anti-classification. One common technical fix is that anti-classification, or it's removing explicit protected variables from the data. This means erasing information like gender or ethnicity and their proxies from the data. So here, proxies mean features that are strongly correlated with the protected characteristics. Like in the case of the recruiting algorithm mentioned earlier, if a person's CV contains references to maternal leave or a woman's college, the algorithm could still make gendered predictions, even if an explicit gender variable is left out. So this may reduce the bias in the system, but its effectiveness in any specific scenario needs to be verified through testing and auditing. And then there's resampling. So in cases like facial recognition algorithm research by Boulamwini and Gebru, where bias is produced through sample size disparity, resampling is one possible way to approach the problem. This might mean only using a smaller portion of the data set, which has a better distribution of examples across all relevant social grouping. Another way to resample is to produce synthetic examples of underrepresented groups. Again, whether these work is a matter of case-by-case verification. It might be that the data set is so unbalanced that there is no way to fix it or save it from creating a new one from scratch. So in cases like the facial recognition algorithm, where bias is produced through sample size disparity, resampling is one possible way to approach that problem. This might mean only using a smaller portion of the data set. Another way to resample is to produce, excuse me, I am repeating myself. So then we're just going to move on to discrimination beyond bias. The important thing to remember here is that discrimination is not the same as systematic bias. Bias in AI systems is a very clear-cut cause for discriminatory practices because of its quantifiable nature. It's easy to fit into the conceptual world of technical AI research. This may be why the conceptual leap from discrimination to bias is made so often. Nonetheless, AI systems can partake in discriminatory practices which do not stem from bias in the system. Rather, we have to expand our object of investigation from the minutiae of the AI model to the whole system of institutions it takes part in. So, again, put succinctly, fair does not mean ethical. All right, so this finally leads to human rights. So under human rights, privacy. Digital records, for example, contain information that can infer sensitive attributes, preferences, or religious or political views. Biometric data can also raises privacy concerns as it can reveal physical and mental health details. Often the real worry is not the data itself, but how it can be used to manipulate, affect, or harm a person. Ethically, privacy is related to personal autonomy and integrity. Following the principles set out by John Locke, the right to control our own lives has been central to our independence. If that right is taken away, it violates our psychological and moral integrity. So the General Data Protection Regulation, also known as the GDPR, is a legal framework that sets guidelines for collecting and processing personal data from individuals in the European Union. The GDPR aims to give individuals control over their data. Any information related to an individual who can be directly or indirectly identified is personal data. This includes names, social security numbers, and email addresses. Location information, biometric data, ethnicity, gender, web cookies, and political or religious beliefs can also be personal data. Pseudonymous data, data that does not directly identify an individual but can be connected to them, can also fall under the definition if it's easy to individuate someone from it. The data subject must give specific, unambiguous consent to process the data. So consents must be freely given, specific, informed, and unambiguous. Data subjects can withdraw previously given consent whenever they want. Children under 13 can only give consent with permission from their parents. So the GDPR recognizes several privacy issues for data subjects. So they aim to give individuals more control over the data. And some of these areas, or some of these rights are the right to be informed, the right of access. So it should be explained how someone's data is used. The right to rectification. So a person has the right to be forgotten and the data deleted. And the right to restrict processing. So a person can deny the use of their personal data. So according to GDPR, you must do so according to protection and accountability principles. You must consider these data protection principles in the design of any new product or activity. And so the data protection principles are lawfulness, fairness, and transparency. So processing must be lawful, fair, and transparent to the data subject. Purpose limitation. So you must process the data for legitimate purposes specified explicitly to the data subject when you collect it. Data minimization. So you should collect and process only as much data as necessary for the purposes specified. Accuracy. So you must keep your personal data accurate and up to date. Storage limitation. So you may only store personally identified data for as long as necessary for the specified purpose. And then integrity and confidentiality. Like processing must be done in a way that ensures appropriate security, integrity, and confidentiality. So for example, by using encryption. And then accountability. This data controller is responsible for being able to demonstrate GDPR compliance with all of these principles. According to the GDPR, if you process data, you must also handle it securely by implementing appropriate technical and organizational measures. The GDPR permits organizations to collect anonymized data without consent, use it for any purpose, and store it indefinitely as long as organizations remove all identifiers from the data. So there are several techniques for data anonymization, and that includes generalization. So it's a method of deliberately remove some of the data to make it less identifiable. Like the data can be modified into a set of ranges or a broad area with appropriate boundaries. Like you can remove, for example, the street address while including the information about the town name. In this way, you can eliminate some of the identifiers while retaining a degree of data accuracy. There's pseudonymization. So it's a data management and de-identification method that replaces private identifiers. So like your name, ID codes, with fake identifiers or pseudonyms. So for example, it replaces the identifier Santiri with Sara. Pseudonymization preserves statistical accuracy and data integrity. The modified data can be used while still protecting data privacy. And then synthetic data, which is a method of using created artificial data sets instead of altering the original data set. The process involves developing statistical models based on patterns in the original data set. You can use standard deviations, medians, linear regression, or other statistical techniques to generate the synthetic data. Data anonymization can be challenging. There are also methods of de-anonymization. So de-anonymization methods attempt to like re-identify encrypted or obscure information. So with safety in AI, the second interpretation of safety in AI is a practical question of designing systems that behave safely and predictably. As AI systems are integrated into ever-widening areas of life, it becomes more critical that the systems are well designed to account for the world's complexity. An efficient and existing example is lane guard technology, which uses machine learning to prevent cars from veering outside their lanes. Machine learning researchers have found that some lane detection algorithms are easily confused with rogue markings, causing the vehicle to veer off the road by following the fake lane markings. The ethically and legally significant question is, what are the acceptable limits to robustness? It is certainly conceivable that circumstances are so incredible that even the system's safety cannot be assured. We can concede that nobody could have realistically seen that coming. Where this limit is, though, is a complex problem and definitely not one that is exclusive to AI or even technology. Nonetheless, the progressive zeal attached to AI future visions has raised questions regarding the limits of safety and the taming of environmental uncertainty in a new way. An example of this can be found in the discussion about autonomous vehicles. And then safety and security. The right to safety is a norm protecting individuals from physical, social, and emotional harm, including accidents and malfunctions. Security means safety from malicious and intentional threats. As a right, safety creates a moral obligation to design our products, laws, and environment so that safety can be protected in unconventional circumstances or impairments. Like in terms of safety, in terms of AI, safety has come to encompass several different conversations, including the following, like AI as an existential threat. The conversation around AI as an existential threat takes a highly speculative and future-oriented stance towards AI. It focuses on asking what threats to humanity AI systems pose if they become too complex to control. So thinkers such as Nick Bostrom or Ray Kurzweil paint a kind of superintelligence scenario. However, philosophers, technologists have called into question the plausibility of a future of superintelligent AI. There's no reason to assume that superintelligence will emerge from developing contemporary algorithmic methods. So with that safety in AI, the second interpretation of it is the practical question of designing systems that behave safely and predictably. So as AI systems are integrated into ever-widening areas of life, it becomes more critical that AI systems are really well designed to account for the world's complexity. You know, a very practical and existing example is that lane guard technology. Moreover, it is an empirical question of what extent AI surveillance is really producing safety. As an example of chilling effects illustrates, the existence of AI surveillance may itself contribute to the feeling of unsafety. Furthermore, it may directly contribute to the actual unsafety and produce harm. AI-powered policing, for example, can lead to direct physical harm because of its predictive nature and the methods of enforcement. And when ubiquitous and automatic surveillance allows even the most petty transgressions to be surveilled and logged, it risks making the consequences of policing more damaging than the original crime. So with the disparate levels of policing, disparate methods of enforcement, and disparate levels of surveillance across communities, most clearly along racial dimensions, it becomes clear that AI surveillance creates a different kind of safety and unsafety for different people. Again, like before, safety becomes entwined with other ethical values such as justice and non-discrimination. And then with the safe and healthy environment, safety also means the right to a safe and healthy environment. Nowadays, this right is threatened by climate change. The effects of climate change are already visible. Storms, droughts, fires, floodings have all become more common, frequent, and devastating. Global ecosystems are changing. They all impact the environment on which our existence depends. The report on climate change estimated that the world will face catastrophic consequences unless global greenhouse gas emissions are eliminated within 30 years. So to summarize, safety plays a role in AI technology in multiple ways. I mean, they all raise questions about balancing normative values while making calls for AI for good. Sound promising, the enactment of rights and normative values in technological systems often collide with a plethora of conflicting interests and deep injustices in the world. When evaluating safety, it is essential to consider what other rights intersect in practice and ask, safety for whom? Now, with the inclusion of disabled folks, according to the World Health Organization, more than 5 billion people live with disability. Now, on the one hand, AI can marginalize and exclude disabled individuals even more. On the other hand, AI technologies have an enormous potential to promote the well-being of these people. AI could augment and support humans with disabilities. So for example, there are several tools for developing communication and literacy that might offer support for understanding those who have cognitive disabilities or complex speech and language difficulties, such as like dementia or cerebral palsy or autism. Moreover, the development of assistant technologies using AI, such as description of images for blind people, speech recognition for captioning for deaf and hard of hearing people, and sign language recognition for for deaf people, and multilingual text-to-speech for options for reading text with those who have cognitive disabilities, including dyslexia, and care robots for older adults, and mobility guides for visually impaired people provide other examples. And then there's that inclusion and gender divide. Like many technology researchers have studied the gender gap or the gender divide, and this gap has many faces. Like first, according to UNESCO, women's digital and algorithmic literacy skills are not the same as men's. Women are less likely to know how to operate or use computers, navigate the internet, use social media, and understand how to safeguard information in digital media. Abilities that underlie innumerable life and work tasks that are relevant to people of all ages. UNESCO estimates that men are around 4 times more likely than women to have advanced information and communication technology skills, such as the ability to program. Women are also less likely to create cutting-edge technology. So according to studies across G20 countries, just 7% of ICT patents are generated by women. And a recent survey of undergraduate students in 29 countries found that early adopters of new technologies are overwhelmingly male. Calculations based on the attendees of the world's top machine learning conferences in 2017 indicate that only 12% of the leading machine learning researchers are female. And so with that, ethical questions regarding AI systems pertain to all stages of the AI system lifecycle, which range from research, design, and development to deployment and use, including maintenance, operation, trade, financing, monitoring, and evaluation, validation, end of use, disassembly, and termination, the entire lifecycle. Addressing the ethical challenges of increasingly advanced AI is crucial. Issues range from bias and fairness to privacy, transparency, accountability, and societal impact. Navigating this requires collaboration between technologists, ethicists, policymakers, and the public to establish ethical principles, governance frameworks, and accountability mechanisms that keep AI beneficial. In addition, AI actors may be defined as any actors involved in at least one stage of the AI lifecycle. They can refer to natural and legal persons, such as researchers, programmers, engineers, data scientists, end users, etc., even including universities and public entities. Embracing ethics is an essential part of the path forward. AI is developing fast, and while no one can say for sure how it will ultimately impact our lives, we can still make a difference. As is the case with most emerging technologies, there are real risks. Still, suppose artificial intelligence is developed and deployed in ethically sustainable ways. I mean, in that case, it may bring positive consequences, not only for individuals or societies, but for the planet as a whole. That direction of development, however, depends only on us. So thank you so much for joining me today, and please take care.